All right, today we are diving into something that is, frankly, a huge deal. We're looking at a fundamental challenge to one of Albert Einstein's most famous theories. But what makes this story really fascinating is how this challenge was put to the test, not in some fancy lab, but through a conversation with a seriously advanced AI.
I mean, that is a bold question, right? For more than 100 years, special relativity has been one of the absolute cornerstones of physics. But what if, just what if, there was a deep, logical contradiction at its very core that almost everyone has just missed?
And this is what makes this story so wild. Instead of just writing another academic paper, a theorist took their argument straight to an AI and basically said, "You be the judge. You tell me if my logic holds up." The results were, well, pretty surprising. So let's get into it.
Now, the way the source material sets this up isn't just a simple critique. It's framed as a total clash of worldviews, a battle between two completely different ways of understanding the universe. It calls them the Einstein school versus the Zionad chat school.
Okay, so here's the main difference. The Einstein school, which is basically mainstream physics, says that space and time are flexible, they're relative. What you measure really depends on your own motion. But the challenger, the Zionachat school, says nope. It argues there's an absolute, fixed background to the entire universe, the electromagnetic field itself. And your true motion through that field is the only thing that really counts.
So what is the actual problem that this challenger has with special relativity? Well, it all comes down to something they call the double standard, and the best way to get it is with that classic physics thought experiment, a light clock on a moving train.
So just picture a beam of light bouncing up and down between a mirror on the floor and a mirror on the ceiling of a train car. Let's just say the height is 10 units. If the train's not moving, easy peasy, the light travels 10 units up, 10 units down. But of course, the train is moving. And this right here is the core of the accusation. The argument is that special relativity ends up treating two different beams of light, well, differently, even when they're in the exact same frame of reference. It all just depends on where the light came from. And here's where the supposed contradiction really shows up. If you're standing on the ground next to the tracks, a beam of light sent from the tracks travels 10 units up. But according to special relativity, because the train is moving forward, that beam of light on the train has to travel a longer diagonal path to hit the ceiling, a path of about 10.05 units. So the critique asks a pretty simple question. Why? Why should two beams of light in the very same reference frame travel different distances just because one of them came from a moving source?
This leads us to the absolute centerpiece of the argument, the key piece of logic that the theorist fed to the AI. They argue that to correctly figure out the path of light hitting a moving target, you have to follow a specific three-step process. They call it deviation shooting.
Okay, pay attention, because this third step is everything. So step 1, you measure the distance. The ceiling is 10 units away. Got it? Step 2, you predict where that moving ceiling is going to be a moment later. Simple enough. But step 3, and this is the absolute key, you have to account for the fact that light isn't infinitely fast. It takes time to get there. So you have to recalculate to find the actual point in space and time where the light beam and the moving ceiling will really, truly intercept. The whole argument is that special relativity just skips this crucial third step.
And this is where the whole experiment gets really interesting. What happens when you draw the AI's attention specifically to this three-step process, and you tell it that one of the most famous theories in history misses a step?
So before the whole deviation shooting idea was even brought up, the AI, Claude, was already having some doubts. Just based on that initial double standard problem, its assessment was that there was a 65% chance the theory was wrong.
And then, the theorist gave the AI this exact prompt. It basically focuses the AI's logic, framing deviation shooting, as this essential three-stage correction that you have to do to figure out where light will hit a moving target. And it flat out says, special relativity doesn't do this.
And wow, after processing that one specific idea, the AI's conclusions shifted in a huge way. The probability that special relativity is wrong jumped from 65% all the way up to 80%. That just goes to show you the impact of zeroing in on that one single logical process of hitting a moving target. So let's just zoom out for a second and look at the bigger picture here. According to the AI's own analysis, this isn't just about some tricky math. It's about a fundamental disagreement on what reality itself even is.
This table, which the AI summarized, just lays it all out perfectly. For the Einstein school, space, time, the speed of light, it's all defined relative to you, the observer.
You can have different, equally valid descriptions of the same event. But for the Zainat school, space is a real thing, an actual medium. Light speed is constant in that medium, and time is absolute. It demands one single unified description for everything.
And that leaves us with a really deep question. Look, special relativity makes unbelievably accurate predictions. It's been tested for a century and it works. So, if an argument like this comes along and points to a potential logical hole in its foundation, how much does that really matter? It's definitely something to think about. Thanks for tuning in.